Hello, this is Mike at GameFromScratch, and welcome to part 3 of our ongoing Paradox tutorial series. Today we're going to be looking at coding. We're not going to look a lot at actually how the code works, but we're going to look at how to add code to your game. So the specifics of how to code particular things, the details, we're going to cover those in future tutorials. So this is mostly about attaching code to an entity, so you can see how programming works in Paradox. So the details we're going to get into a little bit later on. We just want to focus on the configuration part of things. You can see here I'm starting to create a new project, just getting started, a brand new project from the new open from the launcher, and I'll just go ahead and create that. I'm just going to run it on Windows for now. Alright, so any second now Paradox Studio will load up for me. There we go. So here is our new scene. It's got some stuff in it from the start, but I'm going to go ahead and get rid of a lot of it. We don't need ground. Ground's highly overrated. We'll keep the camera. We'll recreate the sphere in a minute. Directional light. Yeah, sure. Skybox. Sure. Alright, so our world basically consists of a light, a camera, and a sky wrapped around it. And here are the pre-configured assets you can see that they've already brought in from the new project. You could have gone ahead and erased all of this. The nice thing, though, is if you use a default starter project, it pre-configures the rendering pipeline for you. And that's a good thing. So you don't really want to jump into this stuff too much until you have to. So you can see you've got this world, this camera is looking at here. You can see the preview render going on. So that's the nice thing about using the default, not scratching it, like not deleting everything right away. So let's go ahead and we'll create a save on that one. And I want to focus on creating a single entity, attaching a script to it. And that's it. That's all we're going to cover today, because we don't have any concept of how scripting works. And the link is a little tenuous between the project itself and your code. So it's not a one-click process, at least not yet. Right now I'm using Paradox 1.2, by the way, and in time this process is no doubt going to change a little bit. So if it has changed from the point that I created this to the point that you're watching this, I apologize. But anyways, now let's look at creating an entity in the world. So just come on back here. As we saw in the last tutorial, just creating an entity as simple as doing this, and we are going to create, well, we're basically going to create that sphere again. So I'll just create an empty entity. It's at the origin, 0, 0, and 0. We'll add a component to it, which is a model. And let's pick our asset. So they've already configured one for us. So we're just using the sphere procedural model. So we just click here and pick it. So now we have this, by the way, that's as easy as it is to create your own assets. Very, very simple, very nice. So we've got this at 0, 0. Let's just move our camera down slightly so it's more focused. All right, let's go ahead and run this guy. So you didn't have to delete all this, by the way. I just wanted you to see that process in action. So now it's compiling the code. You can see down here by the progress indicator. And it's going to run it at any time. I didn't cover that before, coincidentally, but you do not have to click the compile. Any changes that you've made will be compiled automatically when you click play. So it's done and generated. And there we go. So there is our sphere in the world. Simple enough. Great, excellent. We got a base to work with. Now let's look at actually adding some code on top of that. In order to add the code, we're going to have to switch over to Visual Studio. Or you can do this, by the way, completely on your own with text files if you really, really wish. It's in the... So is there actually an open and explore? Yeah, it's right here. If you really want, you can open up your project itself. And it's split into platform-specific code and project code. So overall, ideally, if it's not a platform-specific piece of logic, it goes in here in this getting started.game project. As you can see, it's a traditional CS project with no code. So you could, if you were using text editors, add a CS file here, add it to the project, do it all by hand. Or if you have, for some reason, you want to use mono development or whatever, you can do so. But the easiest thing, and what I hope 99.9% of you are going to do, is install Visual Studio, in which case you just click this button. And it's going to open up Visual Studio for you. If you have multiple versions selected, you can click the drop-down and select which one you want to go with. So here we are. Now we're seeing basically the same thing. Those things we just looked at a second ago, there's the same project hierarchy. So you've got your game project and your window platform. Remember earlier when I picked the number of platforms to run on and I just picked Windows? I could have picked iOS, Android, Windows Phone, etc., or Windows 10. but I only picked one, so only one project was created. If there was a bunch more, more would have been created. If you go in here, this is actually the only bit of code that gets generated. Let me just zoom this guy in so you can see it. And this is it. This is all you're seeing here. And really all this is your application entry point, your program's main. And what it does is creates a new instance of the game class and runs it. So this is what basically kicks off your game to start running. If you don't define your own game class, which we will at some point in the future, so stay tuned for that, but you can inherit your own game class, or you can just use the built-in one, which is what we've gone and done here. So that's it. You'll have, again, if you have multiple projects, multiple platforms, you will have multiple projects like this one that will fire off your game. Now, your game itself is this package right here, the CS project, and you'll notice there's nothing in it. And we're going to go ahead and change that. What you want to do is basically create scripts that attach to your game entities. And there are three classes technically. There's the base class called script, which can be used to create... actually, you probably shouldn't use script. Two classes inherit from script. One is async script, and the other is sync script. And what you've got there is your options between asynchronous programming, using C#5's functionality for basically kind of micro-threading. So things run across multiple processors in parallel, etc. I don't know the specific. I'm not really in depth on C#5 specific functionality, so I can't tell you right offhand what the advantages of using that as opposed to a traditional update base are. But generally, I think an AScript implementation will run better and faster across parallel processors. However, it also creates some complication where you can't have dependencies on, you can't update something asynchronously, for example, and access it somewhere else. There are conditions attached. So again, you have a choice between two kinds of scripts, asynchronous scripts or synchronous scripts. And the difference is right there. Asynchronous means like they kind of happen in order. Asynchronous means they happen in parallel. We'll go ahead and create a synchronous script. So all you do, basically, go to the root of your game over here and go add a new class. Sorry, I can't zoom in yet. There's no productivity tools for Visual Studio 2015, which I use to zoom normally. So all you do, name your class however you want it, .cs. So my demo.cs, like so. So we just added our new entity. Get rid of all of this. Not needed. What we do need to do is using Silicon, so Silicon Studio, Paradox Engine. And that's going to be probably in all of your code. So get used to that one. But that's what brings in all of the different classes that we need. And what we want to do here is now inherit, as I said earlier, we're going to make a synchronous script here. It's sync script. So if you wanted to do it the other way, there is async script. So that's it. You pick one of those two. And we're going to go ahead and use, a synchronous script like so. And nice thing Visual Studio is it says, oh, there's methods you got to implement. Let's go ahead. And the one required to implement is your update call. If you've done any game programming, this makes sense to you. The heart of every game is a game loop. A game loop is just something that runs over and over again and does something like, a lot of the times it's along the lines of check for input, update the physics engines, move things in the world, render the result, and repeat. And it just does that over and over and over and over and over again. So every frame, and a frame can basically, frame generally means every time something is drawn on screen, but this is every time the world updates, every time through this loop. This method is going to be called in your script. So the game is going to run at 60 frames per second, say, or 30 frames per second, or 300 frames per second, whatever. Each loop through, it's going to call this update for your code. And this is where your script can do its thing. And let's just do a quick thing. And this is not going to in any way, I'm going to cover all of these things in more detail. So again, this is not about scripting per se. This is how you attach a script and nothing more. So we're just going to do if game is running. So if the game itself is updating. The nice thing is, as you saw there, we use this game object. There's a bunch of parts of the engine exposed, pretty much all of the engine exposed, so you can code-wise get in and do just about anything you want. We'll see code much more detailed down the road, so don't get too hung up on this right now. But the engine is very exposed to you. You have a lot of access to it, which is kind of a double-edged sword, but nice for the most part. Now, an important concept to understand here is every single script-derived class has access to the entity that it's attached to. So remember earlier I said the world is composed of entities. Entities in turn have components. Components consume assets. Well, that entity, that top-level container, is passed into the script that is attached to it. So we can get access to that entity very simply just by going entity. Well, actually, that's it. So we're going to do if, actually, you know what? We'll keep this very simple. So entity dot transform dot translation, or position. What are you? Position dot x plus equal, and we'll just increment it a very, very, very small amount. It's too small. All right, so that's all we're going to do. Every pass through this game loop, we're going to move the x by 0.01f. As far as the default goes, 1 is here to here, is 1 unit. You can set your units however you wish them to be, but in this case, that would be 1. So 001 is a very, very small fraction of that, but that update loop is called a lot. So this isn't going to give us a heck of a lot of time. So this is a very, very simple script. Now the nice thing about these scripts is they can be attached to multiple entities, so they're definitely reusable. Very, very powerful setup. So that's it. We're going ahead. I'll just do a Control-Shift-B to build it, like so. All right. Flip on back to the studio. Now here's the catch. It should automatically pull it in, and I haven't quite figured out the logic yet to bring in changes. This button should highlight, and a lot of times it does highlight. Sometimes it doesn't. So if you want to make your project aware that that script updated for sure, to make sure that there's no questions or oddities or anything like that, do a quick reload of your project in Paradox Studio when you make or add a script. Now when you change the script, the link is much better, but when you create the one initially, it's been a little bit selective for me on how it updates. So once again, when I add a new script, when I add a new entity in the Visual Studio side of things, I find just doing a quick reload of the project makes it guaranteed that it's going to be there. So now that we have our script, let's attach it. And again, entities are just containers for components. So adding this script to an entity, like this ball here, very, very simple. We're just going to go add a component, scripts, which should actually be script technically, but that's quibbling. So there, we've added a new component to our entity, and as you can see, you can actually, it's a list of scripts. Oh, I guess so. No, so the script was right. My apologies there. It does make sense as a name. So you have multiple scripts can be attached to the same entity. We're just going to attach our one, and this is that one, remember, that moves it along the x-axis. Very key important thing that I screwed up. And you're going to do this over and over and over again. I do it over and over and over again. When you create a new script, make it public so people can actually see it. Like so. So there you go. So now that it's actually aware of it, it saw that it was modified and automatically brought it over. So I'm not going to have to reload the asset in that case. So that's the window you want to see pop up. Now that, so that script is now available. Let's just, there. So now you'll notice it's a bit of a glitch, but if you have an existing one already, close it and create a new one. That's why it didn't show up initially there. So let's start this all over again. So we got our script. We click plus to add a new script to our scripts component. And then very first item, we go ahead and add the my demo. So remember, each frame it's going to move along the x-axis by 0.01f. We could normalize that, the position, the scaling amount. I'll cover that in a future tutorial, don't worry. But this is the process of adding a script. And run it. Compiles, and there you go. So you just created your first ever script. It's updating along the x-axis at 0.01 units per frame. And now it's gone. It's probably somewhere over here and off my monitor by now. But that's it. That is attaching your very first script in the world. Very handy. Now, as I saw earlier, so we have this one sphere model. Let's just go ahead and bring a new one in. So now we have two sphere models, like so. You see both of them in the scene, and I can, again, completely separate component, reuse that same script. Very powerful functionality. So you can add, we could have created the script as the move right script, but more realistically, you do things like session saving or joystick control or you know, reusable code that can access the entity it's attached to. And so now it is attached, and oh yeah, I did. Okay, so now we'll go ahead and run that, and you will now see both entities have scripts attached that are being called each frame and updating them, like so. So that's it. Very, very simple, very, very handy, very, very done. At the same time, you could have done this with the asynchronous class, a sync callback, and it obviously does not have this update. It's not called the same way. It's not called in parallel where it goes, you know, like update, then update, then update. It's called asynchronously, and it's its responsibility to return the results back. So let's go ahead and, where's my tooltip? Oh, async callback, I screwed that up. Async script. There we go, and implement. So this instead calls this execute function, which in turn returns a task. So it's another approach to doing it. Again, this is parallel programming as opposed to serial programming. Now your logic here is going to be about the same. It's just you're going to use an asynchronous model instead. Again, C# asynchronous stuff is kind of new to me, so I am definitely not the person you should learn this stuff from. But the logic is, again, very, very similar. So game is running, like so. And then our logic inside. And so instead of waiting to have our update function called, what we're doing is we're waiting on a return from them to say it's time for you to run, so your next frame. So we're going to do using a keyword from C# called await, and then script dot, why are you not working? Dot next frame. I am missing an import. 1 second. Sorry, my stupidity. We need to say that this is an asynchronous method. Again, another keyword from C#. So what you're saying is wait for the next frame event. So this code is basically running, but when it hits this await, it kind of halts its execution until this returns. So basically we're saying wait on this return, and a bunch of things can wait on this function returning. So that's basically saying wait for the next frame, and in the event that that happens, then we're just going to do the exact same logic. So entity dot transform dot position dot x plus equals 0.01f. So there is the asynchronous version of the exact same script. So you can choose between sync and implement the update, or you can do async and implement an execute, asynchronous execute task. And then you can use this script.nextFrame to determine that it's time that the next frame update has occurred, in which case you go ahead and do your update. So this basically, this code will run through and execute and then wait. So this line of code won't run until this condition is met. So you've got a choice between the two. Again, I am not an expert by any means on this subject, so I can't tell you the advantage of asynchronous versus synchronous. It should, in theory, run smoother, less CPU intensive, because it could be spread across multiple CPUs. But I have not really had a lot of experience here. So which way you want to go is up to you, and definitely do some more research on it. I know I am going to. But those are your two basic scripts. You've got your async script and your sync script, but they're kind of doing the same thing. This is how you can attach either one to any of the components in the world and update them accordingly. And that is the basics of how you program in Paradox. You attach one of those two scripts, and it's updated on a per frame basis. Now there's a third kind of script available as well, called a startup script. And startup script, predictably enough, is called on startup. When things start, it is, instead of being called in the update loop, it is only called that once. And you use these more for doing configuration, global tasks, that kind of stuff. We'll cover startup scripts later on. They use the same model. I can't easily change this example to accommodate a startup script, because They're not called per frame like what we've seen here, but those are your 3 kinds of scripts that you've got. And those are basically how you program your game. Now there's a 4th thing you can do to bring even more configuration over your game. And again, we'll cover this in the future as well. But if you went back, remember back here, when we created this instance of game, we could have just as easily created an instance of our game. And then implemented things there as well. So then you have more control over the complete life cycle of your game. So if you have game-specific logic or initialization that you need to do that isn't appropriate to, or isn't being provided as functionality and you can't do it as a scripting basis, you can also derive your own game class. And then it's just simply a matter of using it instead of the built-in one. So just inherit from the MyGame class and then instantiate it here. Now keep in mind you're going to have to do that for each platform, but it's 1 line of code per platform. It's not a big deal. So really that's it. That is the scripting paradigm or model with Paradox. Now in the future, like what we covered here, this stuff, this logic, moving things and such, that's what we're going to start getting into next. We're going to start looking at a little bit more code specific, and we're going to probably stay a little bit less in the editor going forward. But this is fundamental stuff that you have to understand. So that's the gist of it. Create your script over here, and when you're creating a new one, you may have to do a reload after the fact. Again, reload can be done as simply as in Paradox Studio, file, reload project, and that will bring it in for sure. Now the other thing, and again, I got caught on it here, this was my mistake, is make sure that your class is public, or it's not going to be exposed and it's not usable. But essentially that's it. Then back in your studio, you can attach a script by attaching a script component to any entity, any kind of entity at all. Keep in mind, they all have a transform attached by default, so that's what we updated here. So any transformable entity at all could now be controlled by our code. And I will show you in the future how we can pull for or check for what entities are attached to a particular component. That's coming up shortly. But really, to attach programmable logic to an entity in your scene, it's simply a matter of creating a script and adding a new one to the list and updating accordingly. Now, as I said earlier, you can actually have multiple scripts attached to the same entity. And I'll show you that very, very quickly. So I'm going to go ahead and create another new one. Let's copy and paste for the ease of easiness. And class. And we shall call this move up script. Move up script, like so. And we'll go along the y-axis instead of the x. Oops. Undo, undo, delete. There we go. So, same logic, just going up and down instead. So we've created a new script, this move up script. I'll do a build here. See there, there's perfect. That's what we want. So that showed me that the editor picked it up. So now it should be available here. I can go ahead and just add a new script and apply our move up script. So now this will not only move in the one direction, but up as well. So you can apply multiple scripts at a time to an entity. And again, as I showed you earlier, we can apply it to, so this one now has the 2 scripts applied. This one only has the 1 applied. So scripts can definitely be reused, and multiple scripts can be attached to an entity. Now, one last thing to show you. As I said earlier, you don't need to use Visual Studio. You could have done this all by hand if you really wanted to, using your editor. All the code's right here. It's just CS projects, CS files being created in this folder. It should pick it all up. Use whatever editor you want if for some reason you don't want to use Visual Studio. Now, the key thing to also be aware of, you don't need to use this guy either, Paradox Studio. If you want, every single thing we did today could have been done in code. A lot of code, a lot more work, not a lot of reason to do it for the most part, to be honest, but it could have been done entirely in Visual Studio. I can shut this down completely. So let's make sure we're saved. And let me shut that down. So now we're back here in Visual Studio where we just made this code change. And I can just run my code here. It doesn't need to be run from Paradox Studio. So important thing to be aware of. You can generate and run your code directly from Visual Studio. Paradox Studio does not need to be open. Sorry about that. Okay, looks like there might be a logic error in my asynchronous scripts, which I didn't test. But I'm not even going to debug what they are. The important thing to understand here is that you can now run completely and entirely in Visual Studio if that's your preference. So that's it. That is how you script in Paradox, it's a nice pattern. It's a very straightforward, approachable, and nice way to do things. So next up, we're actually going to get a little bit more detailed into how to do specific scripts to accomplish specific tasks. So we're done with the kind of getting started stuff and overview stuff. Next, we're going to jump into a little bit more technical details. So hope that was useful. I hope you enjoyed that. See you soon. Bye.